Okay, so complex numbers, also referred to as imaginary numbers, is what we'll talk about in this video. We'll add them, subtract them, multiply them, and even use the quadratic formula a little bit. All right, so let me show you my examples, and I'll probably go through one or two of your problems to help you, figure some of those out, because I know they are a little different than the examples sometimes. So example 1, 6 plus 3i plus 4 minus 5i. All we're doing here is combining like terms, okay? Alright, so we're going to combine, I see 6 and the 4, right? We're adding these, so 6 plus 4 is 10, simple enough. And then our I terms as well, like terms. Now it's a positive 3 plus a negative 5, which is the same as 3 minus 5, so it's negative 2i. And that's it. We've combined them, we're all set. That's adding them. Subtracting is pretty much the same thing, but a little bit different because you do have to be careful with that minus sign. So what I like to do is go ahead and change the signs on both things that I'm subtracting. So I'm subtracting 7, so it's minus 7, and I'm subtracting negative 2i, so it becomes plus 2i. So essentially, it just changes the signs of all these values after the minus sign. And then I'll combine like terms basically like I did the first time. 13 minus 7 is 6, and 9i plus 2i is 11i. All right? So you'll do that for all of those. Maybe, I think the adding ones you guys can handle. Maybe let's look at number 2. 7 plus 6, combining like terms again. 7 plus 6 would be 13. And then negative 4 plus 9 would be positive 5. Now try to make sure you do this without a calculator, because I believe some of these questions would be on the non-calculated portion. So be very careful with adding your integers. Don't always rely on a calculator to add your integers. All right, just try to get some practice adding those together. All right, subtracting. Look at something like, I guess number 9 maybe. So we're subtracting 3 and 3i. So think of this as minus 3 and think of this as minus 3i. Remember, change the signs on both of those. Okay, so 5 plus 2i minus 3 minus 3i. So 5 minus 3 would be 2. And then 2i minus 3i would be negative I. So 2 minus I. All right, so let's skip ahead a little bit to multiplying. All right, multiplying we should get a grasp on, but there's usually 1 or 2 tricks about this that confuses people. So multiplying, let's FOIL, let's distribute. Okay, I think we understand that concept. So let me write the problem now so I have a little more space here. 2 plus 5i and 3 minus 4i. All right, so we're distributing, right? 2 times 3 is going to get us 6. 2 times negative 4i would be negative 8i. All right, and then we'll distribute the 5i. So 5i times 3 would be 15i, and 5i times negative 4i would be negative 20i squared. So one big thing people forget is I squared. An I times an I makes I squared. But the other thing that they forget is that I squared is equal to negative 1. We're going to insert negative 1 in here for I squared. So let's look at this problem now. Okay, we have 6 minus 8i plus 15i. But think of this last part. It's negative 20 times negative 1, which would be a positive 20. All right, and now you can combine like terms like normal. So 6 and 20 would make 26 when you combine them together. And negative 8 plus 15 would be 7i. Positive 7i. So 26 plus 7i. So the big thing here, I think we know how to multiply. I think we know how to distribute. Make sure you remember I squared. Okay, make sure you remember I squared is equal to negative 1. That's something we don't do with quadratics. When we do this with quadratics, we never usually change x squared to anything. But with I squared, we do. I squared is equal to negative 1. All right, so I'll let you guys practice those. It's pretty much all the same as that first example. I guess I'll do one more just because let's pick number 17. Okay, number 17, 5 plus 2i, and then 5 minus 2i. So I picked number 17 because it's a complex conjugate of itself. So it's the same thing but opposite pretty much. So, but we're still doing the same math. So distribute, 5 times 5 is 25. 5 times negative 2i would be negative 10i. 2i times 5 would be positive 10i. And 2i times negative 2i would be negative 4i squared. So the big thing here is to remember again that I squared is equal to negative 1. So think of that as negative 4 times negative 1 at the end. Okay? So if that's the case, then we have 25 minus 10i plus 10i, and negative 4 times negative 1 would be a positive 4. So when you combine your like terms, 25 plus 4 is 29. And you'll notice negative 10i plus 10i cancel each other out, right? Because negative 10 plus 10 would be 0. So our answer is simply just the number 29. All right, again, I know calculators can do this, but you want to try doing this without a calculator because you'll notice back on subpart 1, this question was there, and subpart 1 is a non-calculator portion of the EOC. So make sure you can do it without that. All right, now solving quadratics. Oh, why is it down there? Okay, anyway, solving quadratics. So this is just basically using the what should I call it? The quadratic formula. Okay? So quadratic formula is negative b. Oh, this is one thing that you want to memorize too, by the way, because if you look at your reference sheet, you'll notice the quadratic formula is not on it. So negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Alright, so I'm going to leave my example. You already have that on your paper, so let me just do, rather than doing 2 problems, I'll just do one of your problems. I'm going to do number 21, okay? So number 21, we have 2x squared. So again, this is number 21, minus 6x equals 7. So the first thing, negative 7. The first thing is we need this to be set up with all 3 terms on one side and then 0 on the other, kind of like you see in example 19 and 20, how all 3 terms are on the left and 0 is on the right. We're going to do that here. So let's move the 7 over. Now since it's negative 7, we'll add 7 to both sides to move it. So this turns this problem into 2x squared minus 6x plus 7 equal to 0. So now we can use our quadratic formula because we effectively know what a, b, and c is. So a is equal to 2, b is equal to negative 6, and c is equal to 7. So let's plug these in. So negative b. Since b is already a negative number, a negative 6 would become a positive 6. So I'm plugging this in for that, right? A negative 6 would look like a positive 6. So that's why I wrote it as a positive 6. Plus minus the square root. Now, if you're going to type this in the calculator, keep in mind that you would have to use parentheses when you square something like this, so negative 6 squared. If you don't use parentheses, you're going to be getting that wrong, which will result in the whole problem being wrong. So use parentheses or just do it in your head if you know what negative 6 times negative 6 is. 4 times a, which is 2, and c, which is 7. And then remember, this is all divided by 2 times a, which is 2. So let's just clean this up a little bit. Let's start underneath the radical sign. So still have 6 plus and minus, but negative 6 squared is 36. And 4 times 2 times 7 is, I believe, 56. All right. And then, of course, all divided by 2 times 2, which is 4. So we know also we can do 36 minus 56. So 36 minus 56 would be negative 20. And this is where this problem gets a little bit trickier. All right? So negative 20. I need to take the square root of negative 20, but you'll get an error in the calculator if you try to do that because you can't do square roots of negatives. So let's pull this negative 20 out to the side for a minute. Let's kind of put it over here. All right, I need to simplify this, okay? Now the first thing is if it's negative, we automatically have I. Because remember, if you separate the negative from 20, square root of negative 1 is what we call I. So anytime you have the square root of a negative, you're going to have I. All right, but the 20 part, how do we simplify that? Because it's not a perfect square. You know, if it was the square root of 36, then we could just say 6, right? Or if it was the square root of 49, we could just say 7. But it's the square root of 20, and 20 is not a perfect square. But we can break it up. 20 is the same as 4 times 5. And I'm doing this because 4 is a perfect square, right? That multiplies to 20. Remember, we did this way back in the day. I don't know if you remember. But I'm choosing 4 times 5 because 4 is a perfect square. I'm not going to use 10 times 2 because 10 nor 2 are perfect squares. So I'm using 4 times 5. Because when we separate them, the square root of 4 times the square root of 5, square root of 4 is the same as 2. Right? So remember, I still have I over here. And I times 2 square root of 5. So see how that broke down? See how that simplified? So this is the same as 2I square root of 5. Alright, keep that in mind. That's not our answer. But we're going to use that to replace this negative 20 here. So I know I'm kind of running out of room, but we're going to have 6 plus minus. And then we're replacing that with 2I square root of 5 over 4. Okay, so it's the same thing. It's just I replace the square root of negative 20 with the 2I square root of 5. Alright, now I'll notice at this point, all I have to do is reduce my fraction. There are 3 parts here that can be reduced. The 6, the 2, and the 4. Basically everything that's not inside the radical. Ignore the 5 since the 5 is inside the radical. But the 6, the 2, and the 4 can all be divided by 2. So if you divide all 3 of those numbers by 2, what you end up with is 3, because 6 divided by 2 is 3, plus minus 1I, and I guess I can just leave it as I. I don't think you don't have to write the 1 there. And then 4 divided by 2, which would be 2. So this would be your final answer. And you can write that as 2 ways, right? You can write this as, let's see if I can have some room, 3 plus I square root of 5 over 2, and also 3 minus I square root of 5 over 2. And the reason I did it like this is because sometimes I notice on the practice test, they want you to write your answers separately. And if they want you to write them separately, then you're going to write those individually rather than writing it like with the plus minus together. Okay? So that's going to cover it for complex numbers, guys. I hope it was a little bit helpful. And the quadratic formula, of course, being the big thing. But I would say this is probably like 5-8% of your overall test. So it's definitely important that you want to get some of these, especially the easy ones like the complex numbers. All right, I'll end it there. I'll see you in the next one.